Alright, so now we're going to go ahead and get into graphing. Now there's different ways that you can graph this. I really try to focus on the shape of the graph and understanding that exponential growth starts close and gets far away. Exponential decay starts far away and gets close. So by understanding that, I am able to use 2 points to help me graph. Then I don't have to make a table of values and I don't have to worry about lots and lots of ordered pairs. But my two ordered pairs are 0, comma, A, and 1 comma a times b. So that's how we find our ordered pairs. Once we use those, then when we start shifting them around, then we'll shift those ordered pairs. So let's start with just some basic functions that aren't shifted. So here, y equals 2 times 3 to the x. Well, this is a equals 2 and b equals 3. So if I'm thinking about those ordered pairs, my ordered pairs are 0a. So 0, 2, and 1, a times b. Well, a times b would be 6. So those are the two ordered pairs that I'm going to have. Now before I put those on my graph, I want to go ahead and understand what should my graph look like. So I'm looking at the b value here. The b value here is a positive 3. Well, it's always going to be positive, but it's 3. So that means it's growth because it's bigger than 1. So since it's growth, that means it's going to start close on the left-hand side and it's going to get farther away on the right-hand side. Then I'm going to look at this 2 here, and that's positive. So that's telling me that it's going to be above the asymptote. So if I wanted to sketch like a general idea, starts close, gets far away, and it's going to be above the asymptote. So it's going to look like that. It's going to have that general shape. Now I'm going to put the ordered pairs to it. I'm going to put the asymptote on my graph, and I'm going to see what it really looks like. So the asymptote is going to be at plus 0 because there is no k there. So I'm going to go ahead and put this asymptote here at y equals 0, and we can fill in that asymptote. Then I'm going to need 2 ordered pairs. So here are my 2 ordered pairs, 0, 2, and 1, 6. So those ordered pairs are consistent with the fact that now we're seeing that it starts close on the left-hand side. So we're going to start really close to that asymptote, and we're going to get far away very quickly. So that graph is growing. Then we can go ahead and fill in our domain and range. Domain is going to be all real numbers, so from negative to positive infinity. And my range is everything that's bigger than the asymptote, so from 0 all the way to infinity. Okay, so let's look at number 5. Number 5, what you have to realize is that this is really y equals negative 1 times 2/3 to the x, because that b value can never be negative. So that a value is really a negative 1 that we're just not writing because of conventions here in math. So we can think about those 2 ordered pairs. So 0a would be 0, negative 1, because a is negative 1, and then 1, a times b. So negative 1 times 2/3 is going to be negative 2/3. Now we can think about what the general shape of the graph should be. So since it's a decay function, it's a decay function because that base is 2/3. Since it's a decay function, it's going to start far away from the asymptote and get very close. Since it's negative, that means it's going to be underneath the asymptote. So my graph is going to look generally like that. So as I put the asymptote on the graph, and that asymptote is going to be at y equals 0, and that's because there is no k value in my function. Now I can sketch my point 0, negative 1, and 1, negative 2/3. So I know that those 2 tiny little points right there aren't doing much for us. But because we know the shape of the graph, we can say, okay, it's going to start far away, it's going to go through those 2 points, and it's going to get close to the asymptote. That's what my graph looks like. The domain, fill that in, is going to be negative to positive infinity. And then the range here, because it's underneath the asymptote, is going to go from negative infinity all the way up to that asymptote of 0. Okay, so we're going to go ahead and shift these graphs around to the same process that we've just done. We're going to first find those 2 points and then we're going to move them. So just remember from everything that we've done all year, H represents a horizontal shift and K represents a vertical shift. So if we just want to rewind for a second and we want to go back to parabolas, we want to think like y equals a times, hold on, let's put a number in here, that'll make it easier. So if we had like y equals 2 times x minus 3 squared plus 4. Well, that minus 3 made us have a vertex of positive 3, and that 4 made us have that k value of 4. So that's like a right 3 up 4, because if you're graphing that ordered pair, you're going to the right 3 and up 4. So this x minus 3 means that we're moving to the right. Whereas if we had an x plus 3, now this would become a negative 3, because remember it was opposite, you'd be moving left. So kind of keep that in mind as we think about when we're trying to identify that shift. So if we look here at this first function, it is a decay because that's a 1/2 and it's positive. So just thinking about the general shape of that graph, it's positive means it would be above the asymptote. Decay means it starts far away and it gets close. So basic shape is going to look something like that. Now, as we think about those ordered pairs, those two ordered pairs, remember there's 0a and 1a times b. That's not going to change at all. First thing we're going to do is we're going to graph those points, and then we're going to shift them with whatever the shift is that we identified. So because this is an x minus 6, we can go ahead and identify that shift, and this is plus 0. That means that we are moving this right 6. Right 6. So identifying our 2 points, we'll have 0a, so we're going to go with 0, 3, and then 1, a times b. So a times b is going to be 3 times 1/2, which will be 3/2. So as we think about sketching those points, those aren't going to be the points that we actually graph. We have to sketch those points, and then we're going to shift them to the right 6. So 0, 3, and then 1, 3/2. 3/2 is 1/2. So now I have to move each of those points to the right 6. So I'm going to count over to the right 6 and move that point, and then count over this one to the right 6. So these red points are the actual points I'm going to sketch. Now I can go ahead and put my asymptote there at y equals 0. And we've already decided that we're starting far away and getting close. So here I can start far away and I can get close. There's no reason to sketch anything with those purple points, those original points. We're just going to go ahead and keep the final function on our graph. Now our domain, all real numbers, those should be the easiest points that you take on any quiz or test. Your range goes directly with the asymptote. In this case, the asymptote is going to be at y equals 0. And since the graph, that a value is positive, it's above the x-axis, so we're going to go from 0 to infinity. We're going to have everything bigger than that k value. All right, so let's check out our last graph here. Y equals negative 2 times 4 to the x plus 2 plus 2. So we've got a lot going on here. First thing we probably want to recognize is that this is going to be an exponential growth function because the base is 4. And since the a value here is negative, it's going to be below the asymptote. So as we think about that general sketch, exponential growth means that it starts close and it gets far away. And since it's negative, it's going to be underneath the asymptote. So it's going to look something like that. I always draw that sketch. I always want to know what my graph should look like. Just when we were doing even like the positive and negative and even and odd functions, we always knew what the graph should look like, and that helps us check. Like a check and balance system, make sure we're on the right track. So once I've got that, now I can identify the shift. This x plus 2 right here is telling me that it's moving left 2. So remember the x's are always opposite. So we're going to go left 2. And then this plus 2 means we're going up 2. So I like to identify the shift. It's asking us to do that, so we'll go ahead and put it in a box as part of our answer. Now I want to find my 2 points. So my 2 points are going to be 0a, so 0, negative 2, and then 1, a times b. So negative 2 times 4 is going to be negative 8. So those are the 2 points I'm going to have before I do any shifting. So I can go ahead and sketch those. So 0, negative 2, and then 1, negative 8. So I've got those 2 points, and now I want to move them each left 2 and up 2. So left 2 for the first one, up 2, there we go, and then left 2, up 2. Whoops, got an extra little dot there. left 2, up 2. There we go. So now I want to also include that asymptote. So this plus 2 is telling me I have an asymptote at positive 2. So go ahead and sketch that in. And then I'm looking at my sketch, what my graph should look like. Starting close and getting far away means here I'm starting close and I'm getting far away. So that's my function, that's my graph. We can fill out the domain and range. Domain is negative to positive infinity all the time. The asymptote is going to be at y equals 2. So that's whatever your k value is. Y equals k. Now I can look, I can see it's below the asymptote. So that k value is the largest y value I have. So my range is going to go from negative infinity to 2.